All right. Standard deviation is going to be the main thing that we use to look at measures of spread. And kind of the purpose of standard deviation is it partially tells you how concentrated all of the data is towards the middle or not. And the math definition of the standard deviation is it's the mean distance of the values from the mean. So it's the average distance away from the average. And the actual equation that we use for finding those answers is right here. So it looks kind of imposing. Essentially what it is saying is the x minus the x bar tells you how far away a number is from the average. And the answer could be positive or negative. And we actually don't care if it's positive or negative because we just want to know how far away from the middle or from the average it is. So what they do is they square the numbers and then take the square root of it. And then that changes them all to positive. It's the same thing as absolute value. And this little capital E, the sigma, that's the symbol for adding up all of these values and then dividing them by the number of them there are, which is the average. So there's lots of parts of this formula, but it's not terrible. So we're going to go through how to actually calculate one. So here's a set of numbers. We've got 1, 4, a bunch of 5s, 6, and 9. It says, do you think this will have a low or a high standard deviation? Why? Well, I'm going to think that it has a very low standard deviation because to me it looks like a lot of the numbers are compacted right towards the middle. And that would kind of tell me that it's highly concentrated, so standard deviation would mean that the numbers don't go very far away from the middle. That's kind of how I think about it in my head. So I'm going to guess this one's low. Now what we're going to do first is we're going to find the average. So the average was the x bar, and we need to add them all up first. And if you do that, they add up to 50. And then we need to divide by however many numbers there are, and I think there's 10, but let's double check. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which would give me an average of 5. Okay, perfect. So we've got an average of 5. And this is supposed to say x bar right here. It's just the computer didn't really show it right. So we're going to take every single number and subtract the average, because that tells us how far away from the average it is. So we've got 1 minus the average, which would be negative 4. We've got 4 minus 5, the average, which would be negative 1. 5 minus 5, and we got a bunch of those. Oh, that's me trying to talk and write at the same time. Okay, 5 minus 5 is 0. I'll be honest, this is really easy math here. I like this part. Okay, then we get to some numbers that are bigger than 5, so our difference will be positive. And then this line below says x minus x bar squared. So we are going to take the answer from above and square it. So 16, 1, 0, 0, 0, 0, 0, 1, 16. And we want to find the average of all of these values. So we're going to add up the bottom row and divide by 10. So if we add those up, we get 32, 33, 34. And we need to divide by 10 because there are 10 numbers. So we had 3.4. This is technically going to be called the variance. And we don't really need that for now or this class. But the variance, if you end up taking AP Stats, variance is something you go over quite a bit in there. And then we need to take the square root of this answer, which, you know, I'm just going to pretend I know off the top of my head, even though I wrote it down, which is 1.84. this is going to be the standard deviation. So, oh, I'm sorry, I should have put the symbol. Let me get rid of that. The symbol is sigma. That's the symbol for standard deviation. Okay, so we've got another example. So I kind of want you guys to try a little bit of it on your own during this one. So we've got a data set of 2, 2, 2, 3, 3, 7, 7, 8, 8, 8. Do you think this is going to have a low or high standard deviation? I'm going to expect it to be a little bit higher than the other one because the numbers aren't very concentrated towards the middle. In fact, they're like they're more spread out towards the outsides. So first thing, on your own, find the average. So if you need to, just kind of pause the video for a little bit. Okay, we add them all up, and this one actually adds up to exactly the same as the last one, which was 50. And there are still 10 numbers, so we end up with an average of 5. So this has the exact same average as the last problem. So then we can kind of compare them. So we're going to start off by doing the same thing. We're going to take each one of the 10 numbers and subtract 5 from it to find out how far away they are from 5. So 2 minus 5. 3 minus 5. 7 minus 5. 8 minus 5. And then we are going to go square each one of these 10 answers. So 9, 9, 9, 4, 4, 4, 4, 9. Okay, now find the average of all of the bottom values. So that means we have to add them all up, and they add up to 70. And we're going to divide by, there are 10 of them, so the average of the bottom set of numbers is 7. So this is called the variance, again. And we're going to take the square root of that to find the standard deviation. So the square root of 7 is 2.65. And this number is bigger than the last one because I kind of expected it to be because the numbers were more spread out. Excellent. Okay. Third example. I would like you guys to try to do it from beginning to end. So if you want to pause the video right here, pause it, and see if you can find out all of the answers for this one on your own. So kind of the order that you need to do it. Find the average first, the mean. Then add up, or excuse me, find out how far away from they are from the middle they are. Square them all, add that all up, find that average, take square root. Kind of the same approach as the top. That answer will give you the standard deviation. Now the last thing I would like you to try to find on your own is kind of a review from yesterday. It's the 5-number summary. So that would be the min, first quartile, the median, third quartile, and the max. The numbers we would use to find the box and whisker plot. Okay, pause it and see if you can find those. And now that you're back, let me write down these answers for you so you can check to see if you did it correct. Okay, the standard deviation is 2.62. The min is 1. Third quartile is 3. Median 6.5. Third quartile 8. And the max is 9. And I was dumb and I forgot to write down the average. So let's see if I can do that somewhat quick in my head. I've got 9, 12, 17, 23, 25, 32, 39, 47, and 56 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my average would have been 5.6. Okay, excellent. Now, up here, you'll probably notice that I skipped this part up above. So I'm going to make a separate video on how to find out, how to find all of this information on the TI-84 and how to do it on Desmos. For our next example, you need to know how to use the calculator or Desmos to find this information so that we don't have to calculate it by hand every time. Okay, so if you need to, go watch that video first, and then we'll kind of get back to these problems. So it says, who gets the race? A high school track coach has 2 runners and is only able to enter 1 in the big 10K race. He recorded the last 10 race times that the runners Marshall and Alex have posted, and it's tempting to make the decision who gets to represent the school. And, here are the 10 numbers for each. So what we're going to do is we're going to find the 5-number summary for the boxing whisker plot numbers, inner quartile range, and the standard deviation for each person. And then we're going to try to figure out who should run using those. Okay, so here, what you should do is try to find all of that information for both of these runners on your own, on your calculator or Desmos. So pause the video, find those numbers. Okay, so here is the information if you did it correct. The standard deviation for Marshall is 3.98. The inner quartile range is 6. The min is 58. Quartile 1, 59. Median, 62.5. Third quartile, 65. And max, 70. So Alex has a standard deviation of 4.79, inner quartile range of 9, a min of 56, quartile 1 of 56, median of 64, quartile 3 of 65, and maximum of 69. Now that we've found all that information, we're going to try to answer the question, but kind of the problem with statistics is a lot of times it could be interpreted however you want. I mean, like it's up for interpretation is what they usually say. And depending on what you're looking for, you might be looking for something different. So using the summary statistics described by Marshall should represent the school. So if I look at Marshall and I'm trying to compare him to Alex, I guess what I would see right away is his standard deviation is much smaller than Alex. So 398 compared to 479. Now that would mean that Marshall's information is very compacted towards the center. Okay, so Marshall's min is not as fast as Alex's min. Okay, but Marshall is much more consistent, where Marshall has had a majority of his good times kind of all right near each other. And if I were to choose Marshall, I would do it because he's consistent. And you kind of know what type of a race you'll get out of him. His inner quartile range is much smaller, which is kind of the similar information as standard deviation being smaller. And if we want to say Alex should be chosen, I guess the reason we would choose for Alex is that Alex has a faster overall time, and it looks to me like Alex has had a bunch of fast races and then a handful of not as fast races. So kind of Alex would be like the high risk, high reward winner, where you might get a really good time out of him, might not. So if you want to choose Alex, it's because he has faster times. And like I said, it's kind of up for interpretation. Okay, last thing, outliers. And an outlier is kind of like a really big or a really small number that doesn't fit in with the rest of them. So it's an extreme value is kind of what they usually say. Now, there is an actual math way of trying to decide which numbers don't fit in. And it's going to be if a number is more than 3 standard deviations away from the mean, it's called an outlier. And then that would usually mean it doesn't fit in with the rest of the numbers. So we get down here to the examples. It says the number of electoral votes in 2004 for 11 Western states are shown. So we've got a bunch of numbers on those states over there. Find the mean and standard deviation of the data set. And this is where the calculator starts to come in handy. The mean is x bar. This was 10.55. And the standard deviation is 14.3. It says construct a number line showing that the mean and values that are 3 standard deviations in both directions. Okay, let me get another line here. So we've got the mean 10.55. Now, if I go standard deviations to the left of 10.55, that would mean I'm going to go 14.3 to the left. And, well, that would put me into the negatives. So for this particular example, it doesn't totally make sense because going into the negatives can't really happen for electoral votes. But I can go to the right. So if I go to the right, 1 standard deviation to the right would mean I'm going to add 14.3, and that would give me 24.85. And then I'm going to add another standard deviation, which would be adding 14.3 again. So I'd get 39.15. And then I'm going to add 14.3 again. And I get 53.45. Now this is 3 standard deviations away. So if this is our mean, this is 1 standard deviation away, 2 standard deviations away, 3 standard deviations away. And any numbers that are bigger than 53.45 are considered outliers. So if we're looking at our map, California definitely is an outlier because California is at 55 votes. So Cali is an outlier. It says remove that data value and find the mean and standard deviation again. What would happen? So if I basically cross out California and look at just the other states, well, what happens? My average goes down to 6.1 and my standard deviation is 2.81. And you can see that actually changed these numbers quite a bit. Because California was included in the first set, the average was actually pretty high. The average was 10.5, and you know, only one of these is higher than 10.5. So basically every number was below the average because California brought it up so much. Now you get an average of 6.1, which kind of sits in the middle of them. And the standard deviation being 2.8 seems about right because they're not super far away from each other. And in your own words, describe the meaning of standard deviation. To me, standard deviation is how closely compacted all the numbers are towards the middle. Okay, excellent.